Officially, we have begun. Okay, so up to this point, let's think of what we've done in terms of equations and inequalities. With equations, you've learned how to graph them on a graph, right?
Graph a lot of graph.
You know how to do those quite well, whether they're in slope-intercept or in standard form, right? Right? With slope-intercept, it's just real easy. You plot the intercept, and then you use rise over run to get the next point. With standard form, you just find the x-intercept by making y 0, or the y-intercept by making x 0, right? Pretty straightforward. Now, then we did inequalities. I used them in both of those forms, standard form and slope-intercept form, using inequalities. And you did the same thing. The only extra step was you had to shade. And then the last thing we did with inequalities is I introduced you to systems of inequalities. And a system means more than one. Just like in a stereo system, you need more than one thing. If you had a speaker wire for your stereo system, good luck, right? You need more than the speaker wire. You need the speaker wire, you need the speaker, but even then, good luck. You also need the tuner and the CD player or the whatever, right? You need something. You need several things.
You need the monitor.
So, you need everything, right? So, systems of equations. We have now, you have learned systems of inequalities. And now what we're going to look at is systems of equations, okay? So they're not going to be greater than less than, it's going to be equals, right? So suddenly I have two equations here, and I was given a point. And this was the question in the back, okay? Tell whether the ordered pair is a solution to the system. How would I know if this ordered pair is a solution to the system? London.
You just plug it in.
Yeah, you plug it in, right? Do you remember how to do that?
Yeah.
But these are x's and y's. They didn't give me an x and a y.
Yeah, they did.
Oh, that's right. That's what an ordered pair is. X comma y, right? Beautiful. So suddenly, whenever I see x, I can replace it with 3. And whenever I see y, I can replace it with 2. All right, so let's try it. So we got 3 plus 2 times y is 2 is equal to 7. Let's try that. So 3 plus 4 is 7. Now, Gideon, this is where I would suggest you get the calculator. 3 plus 4 is, right? 7 is equal to 7. Sorry, it was the inside joke. Okay. 7 equals 7, right? That's not true, is it? Okay, so that checks. Now, I'm done, right? So I can say yes. The answer to the question is, tell whether the ordered pair is a solution to the system. Oh, no. That's it. Yes, this is a solution to this equation, but we haven't tried the whole system yet, right? So now I've got to try the other one. So we've got 3 times 3 minus 2 times 2 is equal to 5. That's clearly got to be wrong. 9 minus 4 is equal to 5. Get out your calculator, plug 9, and then do minus 4, and you'll get, after the amazing calculations, you'll get 5 is equal to 5.
Oh my
And
god, that was
checked.
so hard.
So my final answer is yes.
Why are you this mean to me?
Right?
Why
Yes.
are you just being very...
Yes, yes, yes. So the answer is yes. All right, does that make sense? Homework tonight's pretty easy, right?
Okay.
Now, okay, so can I erase?
Yeah.
Yes.
All right,
Michael, did you take a picture? It was very...
Michael's not here. Michael will have to just watch it on.
Why, Gary, Michael didn't take a picture?
Is he, oh, he's still
Michael's presence did not take a picture.
Okay.
Have they read out loud this opportunity?
All right, so last one. Okay, 2. Use the graph to solve the... Somebody is talking a lot from back there, and it's not really appropriate. System. And then it says check your solution. Okay, so I'm going to use a different
I've noticed from that sense that he's some of those
Alright, so let's say I had, I gave you this, negative x plus y is equal to negative 7, and x plus 4y is equal to negative 8. And I'm going to graph this really quickly. Okay, so on the homework you're going to sort of see the graph already done. So I'm just trying to do this for you really fast. So, okay, negative x is negative 7, x is 7. So 1, 2, 3, 4, 5, 6, 7, dot, right? Y is negative 7, y is 1, 2, 3, 4, 5, 6, negative 7, dot. So there's my first one, right? And then my second one, x is negative 8, right? And then y is negative 2. Y is, what did I just do? Sorry. X is negative 8, 2, 3, 4, 5, 6, 7, 8. I can't believe you guys let me do that. X is negative 8, right? And y is negative 2, right? Boom. Okay, so now I draw my line this way. Boom. Now, what is this point? It looks like 1, 2, 3, 4, 1, 2, 3. It's like 4, negative 3. Let's see if that's right. That's what they put. Well, it doesn't matter. Let's just say that's 4, negative 3. 4 comma negative 3. Now, I want to know, now on the homework you're going to get a graph like this. You're going to have these equations. They're not going to say what the point is. You have to figure out what the point is, and they're going to ask you, they're going to ask you this. Use the graph to solve the linear system. In other words, the graph would be, according to this, looks like 4, negative 3.
But how
Okay?
did you,
So now that means my x is 4 and my y is negative 3.
how did you get those coordinates?
Yeah.
By where they are. I mean, I just graphed these two, right?
Yeah,
But how
You saw
did
me.
you get those numbers?
The 4, negative 3? Which
Yeah,
numbers?
no, like, so for the first one it's negative x plus y. How did you get,
I copied it
7
from the
and
book.
negative?
So look, if negative x is negative 7,
wait, I see.
multiply both sides by negative 1, positive x is positive 7. So boom, that's my x-intercept. Y is negative 7, boom.
So you
I drew that line.
multiply-
You don't plug it in.
I'm just using x and y intercepts. You know what I'm saying?
No.
Why don't you just plug
Wait,
it in?
which part?
Really line up.
Hey, guys, wait, he has a question. So I just graphed it using the x and y intercepts. When I make, to find my x-intercept, I make y 0. Remember that?
Yeah.
So negative x is equal to negative 7. Positive x is positive 7. So I went to positive 7, put a dot. I make, to find my y-intercept, I make x 0. Y is equal to negative 7. So I go put a dot,
Oh,
draw my line.
okay.
And then I plot this one as well. And then my answer is where they cross, right? And it looks like 4, negative 3. Let's try and see. I don't know if that's the right answer or not. But we're going to just try. So we're going to do, we got negative x. X is 4 plus negative 3 is equal to negative 7. So negative 4 and negative 3 is negative 7 is equal to negative 7. That's true. All right, so it works for the first one. Let's try this one. X is 4 plus 4 times negative 3 is equal to negative 8. So 4 minus 12 is equal to negative 8. Negative 8 is equal to negative 8. That checks. Right? So I can now say that the solution to the linear system, the solution is 4 comma negative 3. I know for a fact because I proved it with my checking. That make sense?
But what if it doesn't do? What if it doesn't?
So if it works for one of them and not the other, it's not a solution. Or if it
Okay,
works
so
for
then you
none
just
of them.
put there is no solution.
What? I'm sorry?
So then, for example, you just put the solution.
It would say, yeah, you would say no solution. Or actually, no, that's not totally true. You would say that 4 and negative 3 is not a solution. Clearly, there's a solution. But sometimes, that's exactly, it's somewhere there's a solution. Unfortunately, sometimes it's slightly more than 4 and slightly less than -3. You know what I'm saying? So it could be 4 in 1 billionth, right? So it could be that kind of thing. So that's it. So that's all the homework is. And then tomorrow we're going to really get into systems of equations and the different ways you can solve them. Okay? So I can stop this.